Okay, so we had logical symbols and non-logical symbols. And so far, the non-logical symbols we've talked about are sentence letters. And sentence letters are going to stand for, oftentimes, atomic sentences. And now we can think about the atomic sentences. How do we know if an atomic sentence is true or false? So consider this atomic sentence, M. And now I ask you, is M true or false? Well, we can't tell, obviously. And so the question is, what do we need in order to know whether or not M is true? And so it seems clear that one thing we need is an interpretation or a model. An interpretation or a model is just what's going to tell us what M stands for. So you might think of it as a symbolization key specifying the meaning of M. Now, if we have such a symbolization key, we'll be in a better position to tell whether or not M is true. So suppose this is the interpretation, the symbolization key for M. M stands for the moon orbits the Earth. Well, now we can ask ourselves, okay, we have an interpretation for M. We know that M, what M stands for. It stands for the sentence, the moon orbits Earth. And now we can ask ourselves, is M true or false? And it seems here that the answer is 1, M is true, right? So on the interpretation where M stands for the moon orbits Earth, we know it's true. But M could have a different meaning. Instead, M could mean the moon is a giant turnip. And so what if M stood for the moon is a giant turnip? Well, then would it be true or false? Well, the answer is in that case, M would be false, right? So clearly we need an interpretation. We need something that tells us what M stands for to understand its truth value, to understand whether or not it is true or false. But notice that's not all we need, because even with this interpretation, the moon is a giant turnip, we could, in some instances, get a different truth value, right? We also need a state of the world, a universe, or a domain of discourse to tell us whether or not this sentence, M, is true or false. We thought that the moon is a giant turnip was false because the state of the world, or the universe, or the domain of discourse, the things we're talking about, in our world, in our universe, this statement is false. The moon is not a giant turnip. But we can change the truth value of M without changing its interpretation if we change the world. So, right, what if the moon were actually a giant turnip? Well, then in that case, this sentence would be true, right? We haven't changed the interpretation of M, but we have changed its truth value by changing the world, right? So for any sentence, for any atomic sentence, whether it's true or false, we need an interpretation plus a state of the world. And those give us the truth or the falsity of an atomic sentence. Okay? So an atomic sentence's truth value is relative to its interpretation plus the state of the world. All right, so we got not A. Now we just need not B to make this strategy work. So what we're going to do is we're going to suppose B to be true. Again, this is for conditional intro. We know it's going to end in a contradiction. At step 8, we can again assert A or B via disjunction intro of 7. At step 9, then, we can assert not A or B via reiteration of 2. And then we are in a position at step 10 to assert not B. And if we have, and so the way we got not B was from a negation intro. I set it up wrong over here. It should have been 3 to 4 and 3 to 5. Sorry, cat interlude. I apologize for that. This is, well, I think his name now is Randy. He's a new cat we adopted. So if we have not B here, then we can assert at step 11, not A and not B. And so that will be via conjunction intro, which follows from 6 and 10. This guy was actually from negation intro from 7 through 8 and 7 through 9. And so now we've got a contradiction if we are able to assert that again. So we're going to reiterate not both not A and not B. So that comes just from reiteration of 1. And so that led us to a contradiction, which gives us A or B, our desired goal via negation elimination of so as I work 2 through 11 and 2 through 12. Okay, so an indirect proof was very helpful to us there. Indirect proof, you just assume the opposite of what you want to show. Show that that thing leads to a contradiction, and that gives you the opposite. Right, so we know, we've talked about the conclusion, and that's going to cue us into what introduction rules we have to use. You can also think about the premises. And premises are things we move away from. So we can now think about what elimination rules would be useful in moving away from these premises to get something that we can use.
Well, how I did it was I started by eliminating the and from the first premise. So you have as line 3, P, and as line 4, Q or R.
Good. So conjunction elimination from premise 1, so that's what that says. Conjunction elimination from premise 1 gives us P. Conjunction elimination from 1 also gives us Q or R. Okay? Now what? Now again, like look, we're a lot closer to our goal here. We've got Q right here. So how can we get Q out of this thing?
You have to get rid of the conditional, or no, sorry, get rid of the disjunct, and you do that by proving not R,
Okay.
which you use conjunction elimination from lines 2 and 3.
Conjunction elimination?
I mean, if not conjunction, if then.
Yeah, conditional elimination.
Conditional. That.
Yeah, you had it right the first time. So we want to say not R from this, and we use conditional elim from 2 and 3. And then if we have not R, so remember our disjunction elimination rule we just looked at. If we're presented with a disjunction Q or R, and we know not R, then Q has to follow. And that follows via disjunction elimination from 4 and 5. Okay, and now what? We're not yet to our goal. So what do we do next?